Hi, I am Tamilian and he is Thirender. Our project name is Railswarm Robotics. Railswarm Robotics is inspired by the collective behavior of biological swarms such as ants and bees, which communicate and collaborate to accomplish tasks efficiently. Now he is going to the abstract.
The abstract of our project is represent a communication system consisting of remotely controlled robot equipped with Arduino microcontroller designed for surveillance and metal detection application. The robotic unit integrates various hardware components including motors and 12-volt battery, a camera sensor for motion detection and a metal sensor for identifying metal object underground. The system is controlled wireless by remote user via internet communication. The software complement is a web application that displays the status of camera and metal detection sensor along with the image capture with via camera. The application also provides functionality to with the image captured review of the image. The project incorporates elements of swarm intelligence, embedded systems and wireless sensor network.
In our project Railswarm Robotics, robotics involves designing, programming, and controlling machines to perform tasks autonomously. When the project is integrated with IoT, robots can communicate and analyze data, optimize the operations in real time also. Now, why IoT in Railswarm Robotics? Railswarm Robotics applies the concept of multiple small robots working together, inspect and maintain and optimize railway operations. IoT improves coordination, data sharing, and decision making among these roles. Our project Railswarm Robotics, inspired by swarm intelligence, where multiple simple agents work collectively to achieve complex tasks. The main objective of our Railswarm Robotics is to automate railway inspection and maintenance using IoT and robotics. The uses of our project is track damage detection and obstacle removal, predictive maintenance using AI, automated railway inspection using sensor.
Next, the overview of our project is the simplicity of mobile industrial robot provide their main advantage of industrial settings due to ease of use, ability to operate via technology well understood by most people. In addition, robots are able to operate most continuously and will be compliant about long work hours, generally increasing efficiency in the manufacturing environment. The main current disadvantages lies in high cost of repair as well as production delays that would caused by failure and malfunction. These factors are very preventive to putting major amount of responsibility on mobile robotics. However,
Next, key component and functionality of Railswarm Robotics, mobile robotic platform and sensor suite. The mobile robotic platforms custom designed or commercially available industrial robots adapted for metro environments and equipped with robots navigation including LiDAR, GPS and visual to ensure accurate and movement, capable of traveling various obstacles within the metro. And the sensor suite of Railswarm Robotics is high resolution camera for visual inspections of crack and other safety defect, thermal imaging camera for detecting electrical components.
next, proposed system of our project is the proposed system enhances the existing swarm intelligence and sensor network deployment strategy by integrating advantages communication architecture and more algorithms for swarm behavior prediction. The system consists of robot controlled remotely via the internet, utilizing an Arduino microcontroller and a necessary controlled remote hardware components. The robotic unit is equipped with motion control and camera sensor and metal sensor and PI version camera for activity monitoring and metal detection. The software unit is comprehensive web application that displays status of sensors, capture and store images, providing detailed history records. The system leverages swarm intelligence to enable a group of robots to communicate wireless and perform tasks cooperatively under guidance. And the proposed rail-swarm robotic system introduced a approach to metro rail defect detection and deployment collaborative swarm to automate robot equipped with an sensor suite including high resolution camera, ultrasonic transference, laser sensors and vibration sensors. These robots are navigate the rail infrastructure and performing real-time data acquisition.
Working mechanism of our rail swarm robotics is data collection, data transmission, processing and detection making, action execution. In the data collection, swarm robots scan railway track using sensors, and data transmission or IoT modules send data to the cloud. Processing and decision making, that AI processing images, AI process the images and sensor data defect faults. Action execution, robots perform tasks such as repairs or sending alerts for major maintenance. And advantages of our project is enhanced coordination. The enhanced coordination's advanced algorithm improves the prediction and coordinations of swarm behavior, making the systems more relatable and efficient in industrial applications. Communications and the integrations, improved communication architectures ensures a more relevant and communication network, reducing centralized infrastructure. And the real-time monitoring of advantages is system's ability to capture, display and solve the real-time data from the various sensors, provide a continuous monitoring and quick response to defect, anonymous or changes in the environment.
The software architecture of our project is system crucial is efficiently operation at the robotic unit level. Embedded software will manage sensor data, accuracy, real-time processing and communication to the IoT gateway. The software will introduce drivers for various sensor algorithms for basic anomaly detection and a communication protocol of wireless data transmission. IoT gateway will utilize edge computing software to aggressive and pre-processed data from the swarm, reducing the load on the central server. The software will also manage the swarm communication and coordinate robot tasks in the central server, host and cloud platform. Will run a database management system to store and organize inspection data and machine learning framework. Example TensorFlow, PyTorch for defect analysis and predictive maintenance, and a web-based application for user interaction and data visualization. The machine learning component will require algorithm for image processing and signal analysis and pattern recognition trained on extensive data set of rail defects. The digital twin platform will be integrated for visualization the rail network and overlaying defect data. The system will require the robotic communication protocol for secure reliable data transfer between the components and the user-friendly interface to display data and manage the swarm and generate reports.
And the discussion of our project is the discussion of this result will be implement for metro rail safety and operational efficiency, the ability to detect the defect early and predict potential failures will significantly reduce the risk of complement and accident, enhancing passengers and worker safety. The manual inspections are very risk for workers. It may affect to accident. The system's ability to operate the challenging environment such as tunnels and elevated sections will expand the scope of inspection and improve infrastructure. The discussions will also delve into the technical aspect of systems performance and analyzing the accuracy and the reliability of the sensor data, the effectiveness of the mechanism, learning algorithms and the navigating complex edge computing data transmission strategies. Key point of discussions: the efficiency of the edge computing and data transmission strategies will be elevated considering factors such as latency and power consumption.
The conclusion of our project is the design of proposed system will be highlighted and demonstrate the technical skills that each team has required thought out the course of engineering program, and every aspect of the current system designs has been analyzed thoroughly with hopes of developing a successful project through planning regarding research, hardware designs and software designs and testing. The team has ultimately prepared for the build phase of project's implementation, and the Rainstorm Robotics project upon successful implementation represent a significant leap forward in a realm of metro rail infrastructure maintenance, transforming for reactive to predictive paradigms, the circulations of research and development, enhancing the robotic sensors technologically and comprehensive and high accuracy defect detection, the translate of profound enhancement of safety and reduction in operating cost and marked improvement in overall efficiency in metro rail system. The core center of the project lies in the integrated approach and the leverage of collaborative swarm of automations, robot equipped with a diverse sensor suite. This allows for a simulation collection of multi-developer data, and the diverse sensor suite. This allows for providing holistic view of infrastructure condition. The implementation of the robot units enables a real-time data identification.
This is main module of our project Railstorm Robotics. The input of our project is ultrasonic sensor. The ultrasonic sensor used to detect the detector. This is microcontroller, and the blue color is relay. The whole module is 5 volt supply, but the motor is 12 volt. The relay is used to convert the supply the battery 12 volts. The main module of our project is Railstorm Robotics. This is the main module of our project. The main input of our project is ultrasonic sensor. Ultrasonic sensor used to detect any object, and if there is any obstacle behind this, it will detect that. And this is microcontroller. The blue color is relay. The whole module is 5 volt supply, but the motor is 12 volt. The relay used to convert the power supply to 5 volt to 12 volt. This is microcontroller, and this is ultrasonic sensor. If the ultrasonic sensor detect any object, it will notify to the microcontroller. Controller will send message to the connected device. If we connected the device to our phone, it will send message to our phone. The whole module is this is the main battery. This is 5 volt, but the motor is 12 volts. The relay used to give the power supply to the motor, and this is a power supply. This is a power supply of the whole project. If we this is a power supply of whole this module. This is a switch key. By using this microcontroller, we set our module to hotspot. If we connect hotspot using this microcontroller, we set the module of hotspot connection. We change our device name to Smart G and set our one password. If we on the switch, it automatically connected to our phone. If the ultrasonic sensor detect any object, if there is any obstacle behind the ultrasonic sensor, it will detect and send notify to the device which we connected to hotspot.
When we on the project device is automatically connected to our device. Its hotspot name is ESP77D9. By this device, ultrasonic sensor automatically detect the defect and send notification to our device by the microcontroller.
If we on the power switch, the module will run, and bottle is the obstacle for this. It will defect the water bottle, and the program will, the module will stop and send the notification to the connected phone. Dear customer, your message object detected. This ultrasonic sensor detect the water bottle and send notification to the mobile which we connected using microcontroller.